It's absolutely not your fault. So, no, but to answer your question, Marty, that's a good question. You don't have to have Linux on your own computer, but one of, again, the main reasons that we're doing this in Python Anywhere is so that we skip all the steps of doing any setup on your own device, and we can just dive straight into doing some kind of coding. And I want to make sure I'm really clear on why we were doing what we were doing yesterday, and we tie it in together. I'm going to point out a couple of things as we go on today and dive more into Python specifically. Um, but really it's to lay the foundation of tools that we're going to use as we build the other things that we're going to build. So this course, again, is not specifically a Python course. It's the main language we're going to use, but this is just a practical coding course. So we're going to build an application, and being able to manipulate files and directories like we did on Tuesday with command line commands is a really basic part of that. So if you wanted to run these things, and I mentioned this before, if you want to run these on your own device, you want to run them on somewhere outside of Python Anywhere, you absolutely can. And you could do it on a Windows machine. You just have to, the commands that we type are going to be a little bit different, but they have a version of them. So you have to go translate those first online somewhere.
Okay, I understand.
Does
So
that make sense?
because we're doing this Python Anywhere, it's kind of like in place of having Linux on our
Yeah.
computers.
So we don't have to
Gotcha.
worry about any of
Yeah.
the setup. And it's already got Python, and we're all going to have the same versions of things.
Yeah.
It's
Okay.
going to shortcut a lot of the beginning steps of getting set up and just make us
Gotcha.
able to dive straight into doing some stuff. So
Cool. Thanks.
yeah, no worries. No worries. Any other questions or kind of thoughts about day one, where we are now? Anybody else stuck somewhere still?
Mhm.
No? All right. Cool. Well, then let's dive in. So we are still in week one. Welcome back. Thank you once again for coming back. Those of you that did. Some people couldn't make it today, but those of you that did, we're going to be talking in a more depth about Python itself. I guess we haven't talked about it at all. So this is really the day that we talk about the syntax and some of the basic parts and pieces. And just to reiterate, we're not doing a full-on Python course. So we will not be diving really, really deep into any of the things we talk about. This is the minimal functional things to get us to the next step. We're going to put off some of these things probably to next week, maybe depending a little bit on the time. But just, again, a quick review of the things we've done up to now. We talked a little bit about it before we started, but we've gone through some Linux environment things and some basic command line interface in Python Anywhere, where you can sign up for free and have a Python Linux instance that you can mess around with. And we looked at file structures, and there's reasons that we do those things early on. We're going to see those same patterns over and over again as we get into the web development portion in week 3, 4, or 5. The way the file structure is set up with that slash at the top, if you remember that picture that we looked at, that is going to be, if you look up the URL at the top of a web browser, if you're looking at one right now, it's going to have those same slashes and same directories. So we're going to see those patterns over and over again. Before we move on, any other questions about stuff we did last time, or where we should be now? Okay. So today we're going to do just a couple of quick slides. I know I said I wasn't going to do a ton of slides, and we're not. This is significantly less than last time. We're going to go back to coding right away and mess around. I do want you to get hands-on. So anybody that doesn't want to, wants to take notes elsewhere, that's totally your choice. But the best way to do this stuff is along with it. Get the errors, run into it, get stuck. And raise your hand if you get stuck. Let me know. We got time to stop and look into it. So a few quick concepts, and then we'll dive into some more coding. The first thing we want to do is talk generally about algorithms. Now, next week, we're going to do more on algorithms. Just want to understand the concepts and sort of high-level stuff about what they are, what that even means, and then we're going to start using them and then dive much deeper into them next week. So first of all, just a broad definition. My definition at the top, right, is just a set of instructions to complete a task. That's what an algorithm is. It's like a checklist or an SOP or anything that we are very familiar with. And I don't know about you, but have come in oddly handy in the civilian world after the military, being just the concept of an SOP or how to use a checklist. That's really what an algorithm is. So a more formal definition here, and again, so I have the example of making a jelly sandwich. Like, think of the directions you would need to give someone to make a jelly sandwich. Maybe you've done courses elsewhere that use that analogy. We might actually use that analogy today. If we got time, we feel like messing with it, we might skip that part. But a more formal definition of an algorithm has these parts, right? So there's 5 parts. So finiteness, it has to finish after a certain number of steps, it doesn't just run on forever. Definiteness, each one of those steps has to be very clear. And then the next 2 things, input and output, we've talked about in other contexts, right? With the hardware input, you put things in with keyboards and the mouse and speakers, things like that. And then outputs, algorithms the same way, right? So inputs are going to be 0 or more things. 0 is an important concept to keep in mind. You do have to designate that there is no input to an algorithm most times. And then expect an output. There should be 1 thing that comes out of it. And then the last criteria for it is the effectiveness. If it's solving a problem, so they should be solving a problem. So when we think about why we're doing this, we don't write algorithms just for the sake of doing it. We do it to solve some kind of problem. And you will, as you do algorithmic practice, feel like you're doing, like, why am I doing this? And that's really where a lot of the math and stuff does exist. Keep promising we don't do any math, and we won't. But this is where it can become complex like that. We're going to keep it high level, but that's really what it is conceptually. So any question before we move on to that? Any questions generally about an algorithm? We're all clear as a concept. Excellent.
So can we
Yep.
use the jelly sandwich as a layman's type in it right now as an example as you go through it?
Absolutely, yes. So think of it as the steps you would need to take. And again, we can go through that actual example when we get a little bit through this next couple of things. If you
Okay.
will. It'll be simple. Yeah, it'll be great. We'll do it that way. It'll be fun. So yeah, just quick kind of definitions of like application development, testing, and debugging. These concepts, and why we are doing things once again in this order and the way that we're doing them. So an application is just a piece of software that's written and designed to do a specific thing. So much like an algorithm, but it's usually like a collection of algorithms. So it's just some directions written on a file in a directory. So all this file directory business that we were messing around with on Tuesday is to be familiar with the structure of where files are and how to find them, how to access them, that sort of thing. Because that's all applications really are. They're accessing directions that are written down in different files. And then a compiler and an interpreter of some kind, in Python's case, it's an interpreter, will take that, if you remember that chart with the human language and the machine language, it'll take the language that you wrote the directions in and interpret it into the machine language. It all goes down into 1s and 0s at some point. So that's really what an application is. It serves a purpose. It does a thing. I put hello world here application in there because that's like the typical kind of beginning point that people go through. And we're going to do something really similar today. We're going to show how to run it, not just directly, but out of a file that's in a directory. And that concept of file and directory is really the idea. So an application can be really simple. They can be really complicated. And they can run in any kind of environments, or not any kind, but a number of different environments, right? So we talked about operating systems. These are the things that run inside of operating systems. So Zoom that you're on, web browser that you're using, those are applications, right? I don't think that's super news to anybody. Debugging, it's generally the process of finding errors. A bug is an error in a system. And this is a systematic way of looking for them and pulling them out and getting rid of them. So we're not going to spend a huge time of this process itself. We'll just kind of naturally run into bugs as we go and deal with them. Part of why I want you to get hands-on and do it is because you're going to make mistakes and run into bugs. The kind of things that we typically run into, and you'll see a lot and try to get a couple of examples today, or we probably will, are syntax and type errors. So usually syntax errors are like the things where misspellings in the way something's supposed to be written in the particular language. So we're going to do Python syntax. And in programming languages, unlike human languages, it's a little different when they say syntax. It's really just kind of the spelling rules and the rules of how you construct statements and phrases and blocks of code, as they're referred to. So type errors are different in that when we talked about data being stored as 1s and 0s, each language will arrange the data that it uses and tell the computer sort of what type it is and expect it to be certain types. So if you try to do things with different types of data, you'll get an error about that. And we'll talk about data types very specifically. It's the very next thing we're going to talk about, and we'll show some type errors and how that what that means exactly. The other sorts of things are logical errors, just mistakes in the logic that you're making, right? If it, you know, the code executes properly, these syntax errors and type errors, those get caught by the compiler, and something will pop up and say this didn't work. You know, your code is wrong. You broke it somewhere, and it's likely to give you a line of code that's wrong. And we'll see examples. It'll try to help you out. Logical errors may not have that. It may not point to that. It may just be, you may get a result. The computer may not break, but it's not giving you the result you want. So it's something is wrong in your code, but it's in the way that you wrote it. Another really common one that's an error is like an off by one error. So we're going to get into the way sets, groups of things are arranged and numbered, and it makes it to where people miscount by one very frequently. So all this is going to become much more clear as we go, but we're not going to spend too much time on debugging. It's really just to kind of talk about what it is. We'll hit it along the way as we go, kind of in each section. There will be different ways that we do it, but we're not going to step through like all the debugging that you can do in a way, and the best ways to do it are best practices. Similar to that, testing is something that I definitely should tell you about. It's important. It makes debugging very much easier because you catch the bugs before they really come up in a use case. There's multiple ways to do it. This is a whole field of study on its own. And I put often neglected at the bottom because I definitely neglect it. I'm terrible at it. We're not going to spend time doing it in this course. If you want to spend time studying something like this, definitely look into, for Python, there's something called PyTest that's really easy to use. And you can have tests written and run probably after we do the stuff that we've done today. Even if you haven't run code before, you could probably follow one of those and learn some basic testing from there. It is really good to learn. I did do one project where was called test-driven design, where you start by writing tests before you do anything else, and then write the code from there. It went really fast. It was great. But I don't know, it takes a lot of discipline to kind of thinking backwards, and I just don't approach all my projects like that. So it's sort of like an honorable mention. We're not going to spend a ton of time on it. And with that, so I was thinking we could actually go through this practice of making a peanut butter jelly sandwich. I was going to ask for a volunteer to see. I'm going to stop sharing my screen there. I'm going to ask for a volunteer. I know, Diane, you kind of mentioned it, so I don't want to just single you out. Michael, you want to go? I want to go somebody that's not. Okay, you're going to go? All right, cool. So what I'm going to do is I'm going to move some of the stuff on my desk. I'm going to set this up, and hopefully you can see me. Can you see my screen? You see this kind of blank area?
Yeah.
Right? See that? All
I
right,
see the blank area.
perfect.
Okay.
So now I'm going to get the actual parts to make a peanut butter and jelly sandwich, right? So we're going to get some peanut butter. I got a bag of bread. So there's a jar of peanut butter. There's a bag of bread. One more second. I got another, we'll call it a jar of jelly. It's, kind of like travel size for the kids, right? I got a knife, a little butter knife. Then I got a cutting board. So it's like a work area. And then I have a rag. There's a little thing to wipe things off with, right? So those are all the parts I have. And this is the area that I have to work in. And what we're going to do is I want you to explain to me as if I'm the computer. So I'm going to play the role of the computer. I'm not going to fill in the blanks for you. If you don't give me explicit directions, I'm not going to do it. I do know how to use things. I know where things are. I know what they are. But
Okay. Do you have what amounts to subroutines for like unscrewing jars and opening bread bags and that kind of stuff?
yeah, see, that's the thing. There are limited numbers of those. I'm not going to give you a list of them though. So you got to kind of figure it out. You got to be
Okay.
explicit in what you're telling me though. And so go for it.
Okay. Pick up the bag of bread in your left hand. Open the top and take out 2 slices of bread. Place the slices of bread side by side on your cutting board. Okay. Pick up the jar of peanut butter in your left hand. Well,
First
first of all,
busy.
oh yeah, there we go. Put the bread bag down on the table.
Yeah.
Okay. Now with your now free left hand, pick up the jar of peanut butter. With your right hand, twist off the top. Put the top aside. Put it on the table. Pick up the knife with your right hand. stick the blade of the knife inside the peanut butter jar and swish it around till you get a quantity of peanut butter on your knife. Okay. Now put the peanut butter jar in your left hand down on the table. And hold down one of the pieces of bread with your left hand so it doesn't slide around. And smear or slather the peanut butter on the bread. Okay. Let's call that a function, okay? Pick up the jar of peanut butter again with your left hand. Repeat the process of swishing your knife around in the peanut butter to collect peanut butter. Okay, put the jar of peanut butter back down on the table and smear it around on the uncovered part of your bread. The other, okay, we'll try that again. Smear it around on, okay. Pick up the jar of peanut butter again. Hey, don't laugh. People make six figures doing this stuff, you know? Okay.
Yeah, this is the job right here. This is the whole thing. That's
Yeah,
it.
okay. Okay. Get some more peanut butter on your knife. Put the peanut butter jar down on the table again. Now your first slice of bread, the one that would be closest to me, hold it down and smear the uncovered portion of your bread with the peanut butter on your knife. Now here's a decision point. I can't see for sure. Do you have enough peanut butter smeared around on your bread to call it to satisfy the criteria?
Yep, that's good.
Oh, okay. Now, with your left hand, pick up. Well, no, put the knife down on the table or the cutting board. That'll do. Now pick up the jar of jelly with your left hand. Twist the top off with your right hand. Now pick up the knife with your right hand.
Right hand's busy.
Oh, you're right. Set the top to the jelly jar down on the table. Okay. Pick up the knife with your right hand. Stick the blade inside the peanut butter jar and collect some jelly. Now smear it around on we'll do it again because you're losing jelly when I'm speaking. Okay. Put the jar of jelly down on the table and use the knife to smear the bottom piece of bread with jelly. Okay, that works. Okay, perform that process one more time so you have an even, a good coverage. Now, place both the jelly and the knife on the table. Pick up the piece of bread with the jelly on it. Okay, with one or depending on, turn it upside down and guide it to match you're gonna set it down on the piece of bread with the peanut butter that's on the cutting board so that it matches the contours. And now set it down. Okay. Now here's where you inspect it to see if it's properly aligned.
I'm just a sandwich maker. I'm not an AI. All right, that's good. We could call it there. All right, great job. That is done.
Aren't you
made
gonna
a peanut
cut,
butter
aren't you
and
gonna cut it in half?
jelly we could cut it in half. I don't know. That wasn't the requirement. Just wanted you to make a peanut butter and jelly sandwich.
Okay.
This
So,
is cool. This is-
Yeah,
everybody
we don't
else.
want him to eat it because it has so much peanut butter on it. The whole, we won't be able to teach.
Yeah, it's all mixed. I can't possibly work like that. Yeah, one second. I'll put it down here. I'm sure one of my kids will come by and get it.
Okay.
All right. So everybody else, how do you think Michael did on that? First of all, thanks for being a volunteer.
That's pretty cool. It makes you think about things.
Makes
that
sense,
you
right?
take for granted.
I know.
What steps do you think anybody else that was watching that wasn't doing it? What steps do you think you would have done that you didn't see Michael do?
When he finished spreading the peanut butter, I would have said replace the cap.
Mhm.
Or maybe that's too minute, but replace the cap on the peanut butter jar and place it back where it was.
Great
You-
call. That's putting the cap back on. That's so that concept, keep that in mind.
Okay,
Things
yeah.
like cleaning up, especially when we start talking about accessing databases and things like that. So if we use the analogy of the jars as a database, if you get anything out of one, you always want to close off the connection
Right.
or else you're going to leave it unsecure and people can get
Same
in there
thing
and
with
get the
this
data.
strawberry or the jam,
Yep.
whatever you used.
Strawberry, good call. Yeah, nice. Observe.
I would say
Um,
wipe off the knife because that's kind of like an error. You want to keep things separate. So
Yeah.
you want to, instead of spreading it to another one, you want to make sure it's stopped before
Mhm.
you go to the next thing. Make sure you kind of say, okay, it's clean.
Yep.
Next thing.
I was gonna say we didn't use the rag at all. So
Yep.
Oh,
that would have been
okay.
Yeah.
good between, but that's good. Yeah, good call. Good call.
Um,
Anything else pops out at you? And again, Michael, I don't see this as taken as like errors or anything. It's sort of different ways they could have done it, other things you could have done. You did do the thing that you were supposed to. It did meet the criteria for the algorithm that we wanted, right? We're just talking about other solutions, basically, or like ways you could have improved, which is again like a code review.
I think the
but
toughest
You can
thing
always-
was
you
trying to
can always
line up.
improve.
I'm sorry. I was
So what-
thinking the toughest thing for me would be to how to line up the bread in the end.
Yeah.
I mean, the way he put it was right, but if there was a way to,
Yeah, that was good. No, yeah, line up the contours. I didn't know how stupid I wanted to play on that part and how complicated I wanted to make it.
See, okay, if this was a real task, right?
Yeah,
You have functions or methods or subroutines for
exactly.
twisting of the top of a jar and that kind
Yeah.
of stuff.
And one of the things that's cool about Python, if you haven't messed with it at all, then we're going to see a little bit of is that it has what's called packages that you could just import and use. And it's really just Python code written somewhere else by someone else that you can just access and take. And it solves common problems, right? So a lot of times you do spend looking through those, finding them, plugging it in, using it. Like you're saying, it's like a pre-built subroutine. So that one part I liked when you said repeat that process. I wasn't a stickler about saying which process. What are you talking about? I knew what you use some intuition, but I did it faster to kind of show you that you can build those things repeatedly.
Yeah,
And we're gonna
you
do
would
it.
have been perfectly legitimate to say which process.
Yeah, exactly. I know that's what I'm saying. If I want to drag it out, but I
Because
thought you were doing
the
well.
computer doesn't know anything and doesn't draw any inferences or have
Nope.
any brains or anything like that.
And it doesn't care about you at all. So
No, not at all.
it'll just sit there and look at you and be like, you're stupid. And it'll spend hours doing it. It's fine with that.
can you go pretty minute with this or real specific? Can you break it almost down to like minutia, like turn the jar counterclockwise to unlock?
Yeah, absolutely. And that's a really good question. That's kind of what Michael was getting at with the subroutine thing. And that's what we're going to touch more on when we
Okay.
talk about frameworks as a concept is that, so one thing again about Python that I talked about, that there are a lot of packages out there. There's a really big community of people that are contributing to it all the time. Is that library of standard things that you could just use, and then the library of things that people have made that you can use that are already built in. But then on top of that, there's things called frameworks, and we're going to use one called Django for the back end of the website that we're going to make. And we're going to talk a little bit about front end frameworks. We're not going to use so many. We're going to use like an old one, just kind of get used for it and let you go dig up the more modern JavaScript based ones on your own sort of afterwards to update the look and feel of the thing that we make. But frameworks are really just built in the code. So like Django is written in Python, but it's just a bunch of parts that you can grab and use instead of having to rewrite like how to do a login for users to log in, or how to communicate through HTTP or something like that. There's stuff that's just built into Django that does that, but it's all in Python. So
I like it.
and no, yeah, I see your question in the thing. So for each step in the particular code per movement should be inserted for the web designing functionality. So yeah, we're gonna get in exactly the analogy. We're gonna draw the analogy out a little bit specifically into what Python and that making the jelly sandwich thing is. We're not gonna make a jelly sandwich with Python, but we're gonna do something similar, and we're gonna be diving into it. So that's where we're gonna go from here. We're gonna dive into our Python Anywhere. I'm blanking on the name of it for some reason. Let me just share my screen again. Any other questions, comments, or anything before we hop over that?
Yeah, no, this is exactly how it always kind of is. You think about it, and what he gave you were high level instructions, and then you have to deal with, okay, each instruction needs specifics, like
Yeah.
how to twist that cap left-handed or right-handed, and
Right.
you know, so it's that thinking and breakdown to take out any assumption. People make assumptions.
Mhm.
You could talk to a person and they have done this, so they make assumptions and fill in the gaps, and they take your instruction, and eventually you can say, just make me a peanut butter and jelly sandwich and leave everything else out.
Yep.
And a computer cannot do that ever, ever,
Yep.
ever. It
That's it.
knows nothing. It knows, is there voltage on a wire? Is there not? That's it.
That's
And
it.
you have to fill in everything. And sometimes it's a matter of taking that what we just watched, and then take each and every single step. And how do you know that you have 2 slices of bread?
Yeah, exactly. So
You have to define that. And so now
Gotta
you got to
define it.
take that and break it down again. And each step becomes its own little subroutine. You know, it becomes its own, almost its own little program,
Right.
because you cannot make assumptions about turning left or turning right. You have to be explicit.
Yep, very true. And it's also very easy to overcomplicate things because of, you'll get so set on finding the solution that you'll forget to look for things that have already found the solution or faster ways of doing it, right?
Right.
So
okay.
it's like this crazy balance of making sure that you hit all the minute steps and that you don't spend too much time looking at minute steps. So, that's the fun part, I guess.
Developing your personal love affair with the person that out there that posted the code that does this, that you don't have
Yeah.
to reinvent their wheel.
It's amazing. Yeah. I love that stuff. So, all right. So if you're following along, and again, I'm going to keep encouraging you to do so. If you haven't been, or if you're on the fence, we're going to be in Python Anywhere, and we're going to start off in consoles again, and we're going to go into our, you should have probably one bash console still there. If you have more than one, I know some of you, when I went and looked, you had a couple. That's cool. Don't be afraid to close them out. I just destroyed one that I was messing around with earlier. Just hit this X to get rid of it. You have a max of 2 on the free one. We're going to be using 2 today, so we're going to need both to be freed up, just so you know. So
Should we open this up for ourselves?
yeah, definitely do
Okay,
it. Definitely
okay,
open this
you
up for
do that.
yourselves. Follow along, maybe move mine on the side. I can make my screen larger if it's too small or something. Like if you have to split your screen in 2 or something, let me know. But
That's
it's
what I was
best if
trying
you
to
follow
figure
along.
out how to set up the screen so I can follow you and follow what
Mhm.
I'm doing.
Yep. Do that. I'm going to pull up this chat, make sure I don't miss anything.
Yeah, you need to make your screen smaller so I can get to my
Make
What do you
my
think?
screen smaller.
your depiction of the Python Anywhere
Mhm.
console.
But
It's
that's,
not, it's your computer, Michael. It's not
Yeah.
his.
It is, okay.
Yeah.
I can't see the, the Gmail or the, where you enter things. in
Click
the-
anywhere on your screen and then hit the escape button. You should come out of
Okay.
full screen and you should be able to see your taskbar.
Oh, I knew that.
There you
Okay.
Nice, thanks. Thanks for that. All right, cool. So
That's the iterative process of learning. You relearn it 5, 6 times, and eventually it sticks. Yeah.
absolutely.
You got
It's the
no
whole idea of
idea.
practice. All right, so in your consoles, here from dashboard, go to consoles. We're gonna jump back into a bash console, and there is a
I'm having trouble bringing it up.
uh-oh.
Oh, there it is. Okay.
There you go. You good?
Yeah.
All right. So last time we talked about a handful of commands in Linux. Today we're going to focus more on Python. Before we do, I'm going to do one more quick thing. Swear it's not going to be a Linux course. We do one more command that I want to make sure we know. So last time we did looking around where we are with a print working directory to show the directory we're in. We did list to see what else is there in that directory. It has a bunch of flags to show different things. Now there's another thing that we need to do. Oh, we also made directories, made files, and deleted them. Now we need to be able to change the working directory and move around within the system. So just a real quick command is CD, which stands for change directory. And again, let me know if I need to zoom in to make the text larger, if it's easier to read or something like that. And then you pick the directory that you want to go to. So you CD, lowercase, all lowercase when you do these commands, space, and then the directory you want to go to. And if you think about that file structure that we talked about before, the Linux file structure with the slash is the top. So if you just do that slash, that's where you'll go. So now we've gone from the home, this is the abbreviated home thing, this tilde is the abbreviated home, to our, it's called root. And so now if I do the list and stack it up the way I like to, you see it's totally different stuff than what was in my home directory. We can see that we have other subdirectories. Don't worry if yours doesn't look just like mine. You know, I've messed around in this probably a little bit more, so there may be other things installed here. But again, thinking back to that thing that we visualized, there's our home directory. So again, we can just go back through this using the change directory command. Don't forget to use tab completion to make sure that thing is there and to go to the home directory. Again, if you do tab twice, it'll show you what's in there. It's kind of a way to peek before you go. So if you hit tab to finish the home and then hit tab again, it'll show you all the options. Now, when you do this, and again, there's something else I want to point out. What the reason I'm doing this now is when you do this, you're only going to see your own username, right? Let me just go ahead and actually go to the home directory. I'm going to clear this screen and I'm going to list the contents of my home directory, which yours won't look like this. Now, what are all these? Here's my username.
These are all the directories that we have given you permission to look at.
Exactly. So what does that mean if we take it from how you gave me that permission to what we're looking at here? It's a little bit of an esoteric question.
Ask the question again.
What does that mean if this we're looking at the Linux file structure, and how did you give me this permission?
I don't know.
I'm
The
gonna
other
say
night, we,
administrative rights.
We went into, yeah.
Privilege? No?
What's that? Yeah. So what you did was you went to the website, right? And you just went to the accounts and you pressed around, you clicked on a graphical user interface that's set up for individual users, right?
right.
Yeah, okay,
And then in
this
the
is-
background, all it did was a very simple adding you as users, as if like if this was we were all using the same machine, and this you think about this as a physical device and this just being one Linux instance on a device, is as if we're all users on that machine and I'm logged into it now, and you know, I'm like the admin user and I can see all of your stuff, and you guys are just individual users that you're less privileged, right? So the privileges, yes, it's the same thing. That's all it did. So the relevance there though is that that's really where we're going here, is that those simple things is being able to work on the command line like this. And then all they did was build a front end, and now they have a piece of ed tech that's out there that they can charge money for. This is something they do have prices and stuff on Python anywhere, right? So this is a business. You guys are making money off of this, and this is an example of a web application and how these things are connected all the way around. So what we're doing right now, hope you see that again. You fill out a form on the front end of a website, and it comes and does things here that we're seeing. So that, and also if you look up the URL up here in the top of the browser, it's the same format as these file directories that we're looking at, right? Because it's the same thing. The same thing. Oh, patterns are going to be repeating over and over again here. So the last thing I want to say about CD is if you're ever lost when you're moving around things and you do CD with no arguments and nothing after it, it just takes you right back to your home spot. So if you ever get lost, you don't know where you are, that's a good way to get back. All right. So last thing about that, I promise. Any questions before I move on from that?
What's the command you use to clear your screen?
It's the word clear. Just type clear.
Just type clear.
Yep.
Once you get to the one root, whatever.
Yeah. Whenever you want to, yeah, you just hit just CLEAR, no spaces, and everything is all lowercase.
Jeff, how do you get out of when you go into CD and you look at the directory, how do you get
Mhm.
back?
Oh, if I say like, if I wanted to go up a directory, that's what these two dots mean. If I want to go up a directory, but I want to see what's there.
No, you want to leave back to the main one. Like I left my console.
Uh-huh.
I went into a directory and now I don't know how to get out.
So what do you see when you do print working directory?
When I say what?
When you do PWD, type PWD, and what does it show you?
It tells me my directory that I'm in.
Yeah, which is what? Is it just a slash?
I play here.
What's-
Play here.
Okay. So just type, if you just type CD by itself, it'll take you right back to your home. So just do CD
Okay.
with nothing, and wherever you are, like if I'm all the way down in root and I just hit CD, it's going to take me right back to home.
Okay, that's what I was asking. Thank you.
Okay. Yep. Sure. Cool. All right.
Okay, can I have some?
Yeah.
Okay, when I first turned the Bash console on, I was playing with it last night,
Mhm.
moving files around, that kind of stuff, right?
Sure.
That's all in a different directory someplace, okay?
Yeah.
If I turn on this, basically the console is blank. I type in ls-lh.
Yep.
Right? I get this ls cannot access dash no such file directly, and I get ls cannot access LH, no such file or directory.
So, yeah, so you're probably doing spaces in the wrong spots, right? So when you do a flag on any of these things, when you do ls, you do one space, a dash, and then whatever flags you want with no spaces. So these three
that's
characters,
okay. Let me try that.
yeah, that's probably what you're doing, because that means that, you get this error, right? It looks like this. So that's because I did a space between the dash and the flag. Don't do that. Keep the flags and the dashes together. So, all right. So what we're going to do is we're going to dive into Python now. So we're going to do Python's version of stuff. And yes, good point. No, the numbers are randomly assigned, so don't worry if your number isn't the same. What's up, Antoine? You got a question?
I didn't see that command you used at the beginning because my laptop was acting kind of funny because I need to update some drivers. But
No worries, dude. It's just CD. It's just change directory.
it was only change directory. Okay,
That's it. That's the one we did.
I did that one then. Yeah.
Cool.
Thank you.
All right. Yep, no worries. So what we're going to do is instead of opening up a new console and going back to the console list and going into those Python consoles, I'm going to show you can open one within here. So it's going to be similar to what we did with Vim, where people got stuck, right? So the first thing we're going to do is going to go in and out of it to make sure everyone's comfortable with that, to make sure no one gets stuck here in the Python interpreter. So what we do to get there is we just type the word Python, and I usually, out of habit, put 3 at the end. I'm not going to get deep into why Python's versions are the way they are, but versions are really important in Python. So 3 is the latest big version, but this will open up what's called the Python interactive shell. So it looks very similar, but it's going to give you this little 2-line warning that says the version of Python that we're using, which is 3.10.5. Not the absolute new, there's like a 3.11 out there. Sometimes that becomes relevant, but again, we're just not subject to this. Worth reading up on though, if you really don't want to, if you really want to use Python a lot. Versions is crucial to understand. And then we can look over here that the input prompt thing has changed to these 3 greater than signs. And so now all the commands that we've talked about so far in Linux are not going to work. So clear, ls, all that stuff, you're just going to get errors if you type that in here. They're not going to work. So if I type in ls, it's going to say that's broken. And there's no way to clear this. So that's going to get kind of annoying. It's going to get cluttered. Just giving you a heads up, the screen's going to get cluttered. If you like a clear screen, you'll be happy when we go back to bash. So what we're going to do is walk through what happens in Python and the basic pieces up to a little bit more complicated structures. And then we're going to move out of running it here. And running Python out of a file from other places, from other locations. So what we're going to do is go through the basic data types that are built into Python. So we talked about what data is. It's 1s and 0s ultimately. But each language, like I said, will type the information that you give it with whatever kind it is. So the basic data types that we start with are numbers. You can write numbers directly into Python, and there's 2 kinds of them. So you have integers, so your numbers 9 through 0, 0 through 9, however you want to go with it. And then you have floating point numbers. And what this is doing is it's just returning what I give it, right? So you saw what I did when I typed in ls. It gave me an error because it doesn't know what ls is.
Miss.
Yeah, ls, that's the command from Linux. It said it doesn't know what that is. So it gave me a warning, but it knows what 9 is. It knows what 4.5 is. So this is called a floating point number. So anything with a decimal is a floating point. Now these you could do mathematical operations with them. They come in handy to solve simple problems. Again, we're not going to do a ton of math. It's very basic arithmetic that you can do and just show you how you do it, right? So you could just do addition, right? And it'll give you the answer, right? So 9 plus 3 is 12. Subtraction. Multiplications with the asterisk. So you put the asterisk in there. If you need to do exponents, then you put 2 asterisks. So this comes in handy again when we're writing algorithms and doing things. Sometimes we want to use exponential something. So, you know, maybe we're figuring out in binary, we're figuring out how many bits or something we need. So, you can also do division, but you got to be careful with that. So I told you there are 2 kinds of numbers, like there's integers and floats. Again, I promised it wasn't gonna be a math course, and it's not. But you have to be aware that if you divide 2 integers, Python's going to return a float. So we don't want to just assume if we're writing an algorithm that the output of dividing an integer is going to still be an integer. Sometimes it'll change the result of the function. So there's a way to get that to not do that. Let's do what's called floor divide, and it'll give you this version of it. There's another cool thing that comes in handy for solving some problems called a modulo. I'm not really sure how to pronounce it, actually. If someone knows, they could absolutely correct me. But it'll give you the remainder of a division operation, and that's just the percent sign. So you do like 7 modulo 3, give you 1, right? Because if you did 7 divided by 3, it would be like 2.3. And if we did 7 floor divide 3, it'll give us the remainder, or it'll give us the rounded down number of 2. So that's kind of different ways that Python treats numbers. All coding languages are going to deal with numbers slightly differently. And if you're going to get into using Python and coding with it, you're going to really want to understand how it deals with numbers, especially if you're going to start writing things for, like, I don't know, financial things or anything like that, where the accuracy and how numbers are handled is relevant. So then the other major type of things that you deal with all the time, as far as data goes, are called strings. And strings
Can I ask a question before we move on?
Yes, please do. Go ahead.
Do we have any exponents available other than squared, other than 2? Like, can you cube
I
something?
think you can keep going with you just throwing more exponents. Let's try it out. Let's see.
Okay.
Nope, doesn't work. So, yeah, I don't know. That's an interesting question, how to figure out how to do that. I'll leave that to you. You find out how to do that. You tell me.
The
Is it the
you only
carrot?
use 2 x. Yeah, the exponent itself is in the value.
Right.
It's in the
Right.
Yeah, so it's not going to be depending on if you use a decimal, a float, or a integer. It's not.
Right.
It's always going to be in the value.
Yep.
So it's not. Yeah, sorry.
Yeah, no worries. And again, I don't want to get too deep into any of the mathematics. I just want to show how the functions can be used in Python, right? So
I was gonna say, but you can cascade those though.
yeah,
Like,
you could do all kinds of stuff. You could start getting complicated, put them together. Those are the basic functions that you're going to be able to use, and then you could start going wild with it, right? So,
Do you think there might be a package for this? I would think.
there's one called Math, and it's great, and it's got all kinds of stuff in there. And that's what I'm saying. There's a Python package called Math, and it's got all kinds of cool stuff in there. This is, again, just showing the really basic nuts and bolts. Yes, there's all kinds of sexy mathematical things in Python. We're not touching any of that, obviously.
Did you say that you can increase the size of your type here? Because it's hard for me to see.
Yeah, absolutely. I can make it larger. Is that better?
Okay, yeah.
Yep.
Okay.
You know what I'm saying? I'm sorry, I can't clear this out. It's gonna keep getting a little bit cluttered in this
Right.
Python interpreter, so it's just a little bit cluttered this way. But,
Okay.
How are you doing that? How are you making the type bigger?
control and then plus makes things larger. And then control small
Okay.
S or minus makes it small.
But you can do that as the host, right?
You should be able to do it on your own as well.
Well, I can see mine, but I was trying to read what you wrote
Right.
so I can type it. Okay, no
Is that
problem.
better?
12, yeah.
All right. So those are numbers as data types. The next number, or next data type is a string, and that's basically text. So it's anything. I'm going to type in again a literal string is what it's called. It's called literal, and it is anything that is between quotation marks. So you could do single quotation marks in Python, and that's acceptable. That's okay. Or you can do double quotations in Python. That's totally fine. But you can't mix them. So you can't do one or the other. You'll get an error. So there's a syntax error that says, nope, that's not good Python. You can't do that. So what does that mean to put a string? So like any sentence, word, anything you want. That's a string. Numbers. could be
If you
strings.
put a string and you put a number in between the quotes, is it casted as a string?
Yep, that's totally a string. And that's the thing. So like if I put so right there, which is this number 9 right here, that's a string.
That's a
Um,
string.
It's
Okay.
not a number. And so what we're going to do is you could do similar things using a lot of the operators we were doing before to strings. You could do different things with strings than you could with the numbers, but you can use a lot of the same operators. So for example, you can add two strings together, what's called concatenating them, right? So I can show you that it's not, that they don't treat numbers like numbers by doing a string number 9 with open and closed quotations, and then plus, I'm gonna do another string, I'll put a space inside this one, and the number 9. And when it comes out, it should be 2 9s with a space in between them within one set of quotation marks is what the result is going to be, because it's going to concatenate those together. As opposed to, again, if I do integers, it sums them. So it treats integers and strings differently. You can check to see what something is, but before we get to that, I guess another cool string thing, we're going to get too deep into stuff you can do with strings, because there's a ton of stuff you can do, and you're spending a lot of time working with them. We'll do more next week when we do algorithmic stuff. But you can also, again, you can multiply strings. So if we want to do multiply me, and then we just do the multiplication and pick a number, it'll write the string that many times. So pretty useful things that you could do with that. It's nice that you can just manipulate strings that quickly. And again, we're just kind of skimming over this now. We're gonna get a little deeper into strings later, because it's a huge portion of what you're gonna do on anything. You're gonna deal with strings. Strings and integers is pretty much it, or strings and numbers. That these 3 sets of data is really the thing you're doing. So from here, we're going to talk about data types. They're still data types, considered data types, but they kind of store other data types. So these are go ahead.
Does Python use the difference between the single and double quotes in the same as like Ruby? Because Ruby will allow interpolation in a double quote, but not a single quote. Is there reasons for using the single versus double?
No, it's just more convenient. It's just another option. But if you want to use an apostrophe, right? You want to take the single quotes and use an apostrophe, you use double quotes.
Mm-hmm. Exactly. So if I want to do like, I'm a string and use this apostrophe, I'm going to want to use double quotes for that, because this apostrophe here otherwise will be interpreted as a single quote, right? So that's a valid string.
Right. So like in Ruby, you could do that, but you'd have to put a backslash in front of this.
Exactly.
So you want.
Here's that same thing. This is what you're asking about, right? So you can escape this. So this is the option. You can either use double quotes on the outside, because so if you just use a single quote and try to do that, you'll get a syntax error, or you can escape it like you would in Ruby, right? So you can hit the backslash in front of it, and it'll make it a valid string. So, and that's true for any character in there. There's special characters that go in there, like a new line, a carriage return, that /n. You have to escape those sorts of things if you want them to actually just be printed. So yeah, again, we're getting more into what strings and how you mess with them, what you do with them, because it's a big thing that we do, or that you're going to have to do no matter what you're doing. So, any other quick questions before we move on to the next sorts of things? All right, cool. So the one that I definitely wanted to hit on, another one actually before we get to the collections, I almost forgot the Boolean values, which are true and false. So those are 2 things that are in Python, and the way that they're written is with a capital T and a capital F for true and false. And then we use these sorts of things for when we start building logic and real simple logic stuff, and we start using comparisons. So we had all these mathematical operators that say, the pluses and minuses, those all look the same. When we're trying to see if something is equivalent and equals, then we're going to do 2, what we're normally saying is equal signs, right? So if I want to say, I want to check to see if false is the same as true, this is how we would write it. So the 2 equal signs means equality between 2 things. I'm just going to say that it's false, because that's obviously not true. We'll do more of these comparisons here in a minute, but I definitely want to go into the way that these data types are now stored in other things, right? It's the other data types that kind of collect these. The first one of those is called a variable, which just like it sounds. It's something that could be changed out, but think of it like a bucket, right? It's a container that you put one of these data types in. So you're going to put integers, floats, strings, or any of the other data types that we're going to talk about inside of a variable. All these things that we're talking about are broadly applicable to all languages. All languages are going to have variables, but the way that they do variables, the way you write them, and the way they behave are going to be slightly different. So we're going to talk again all through Python in this. And the way that you write a variable in Python is very simple and straightforward. You just come up with a name and write that name. There's some restrictions and there's some conventions, right? So there's some things you can't do. There's some words you can't use. You can't use words like if, because that's a word that Python has dedicated to a special purpose. You can't use int to mean integer, because that, again, that has a special purpose, a special meaning. So any of those reserved words, there's a whole list, so I'm not going to go through all of them. Something worth knowing that you cannot use. You can't start a variable, sorry for this word, with a number. So it can't be like the number 9 and then something. That's an invalid name. Generally speaking, the style-wise, they're lowercase words. And they have a number of ways you can approach it, right? So what you typically do is you'll write, say, a variable. And if you want to use 2 words, like you want to say my variable, there's a couple ways to approach it. You can do what's saying in the chat here was called camel case, where if there's 2 words together, instead of putting a space, you just capitalize the second word, but the first word is not capitalized. So variables are never capitalized in the very beginning, but you can put, say, variable, and that's a viable name. There are style guides in Python that suggest doing it one way versus another, and what they suggest typically is using an underscore. So if you want to do that, those are the sort of the ways you name it, but you can use really anything you want to. Use a single letter, X or A or whatever you want to be, as long as it's not like a capital I, because I'd be confused for 1, or a capital O, could be confused for 0. And then the way that you set that value into that variable. So you imagine the variable is a bucket, right? So let's just do a variable A. It's the first variable that we're going to use. And then we want to set it as something. We do assignment. So resist the urge to read this as equals. It doesn't mean equals in Python. This up here means equals. This right here means is. So when you're reading out loud, when you're reading code, the variable A is what this phrase right here is saying. So the variable A is, I'm going to set it to 7. So it's the integer 7. So now that I've declared, I've given Python the statement A is 7. If I reference, refer to, or call, use A in any way, it's going to give me back what's inside of it. So that's what variables do. So they hold things, they put them in there. They can be strings, like we were talking about earlier. So look at B. B is the string 7. And then we can use them to compare, like we were before, and say, is B equal to A? It's going to say false because one's a string and one's not, right? And there's cool things you do with it, like you can change the type. So you could say C is the integer version. So you just type int, open parentheses, the variable B. So the integer version of that. So that's going to put it back to 7. So now if we compare A to C, they do equal each other because it's 7. So this is what one of the things that we do with variables, put things into them. Does that make sense?
Yeah.
Okay.
So you cast to get to C, you cast the string, which is B, into an integer and turn it into an integer, right?
Yep. So
Okay,
all
okay.
these things are just, so a variable is really just a named space of memory. You're just saying these, in this case, 8 bits, right? 8 bits to take up one character. I want 8 bits for a string. I mean, it's probably a little bit more than that. I'm not going to go super deep on exactly if that's exactly what it's using, but that's the rationale here, is that this space for this number 7 is going to be called B in our memory while we're in this little program right here. So it's not stored forever, but it's going to be what we use now. And we can change that. We can change B to whatever we want, but it's really just saying that the space of memory is going to be this thing. And then we could change what that is. And so when we did it here, we took what was in B and we set it to another space in memory in C. And so it's labeled as C. So it's derived from the information that was in B. We changed it a little bit and we put it in C. Does that make sense?
Yeah, perfect sense.
Cool.
Okay.
All right. Any other questions before we move on? Nice. Nice. I know it may be a little fast for some of y'all, but that's the idea. Stick with it. If you can't keep up writing it, sit back and watch, write it when you can. We're gonna dive in. So the other collections get a little bit more complicated from here and have not complicated in the sense of like hard to understand really, but they're going to be just larger containers. You could put more things into them. You could put several variables into them. You could put themselves into themselves. And so all of these next 4 types are that, and they have slight differentiations between them. There's reasons you use one over the other. I'll highlight the 2 most common that you're going to be using, especially when you start, and why you would want to. But the first kind that we get, and if we compare all 3 of these variables that we've already set, A, B, and C, and I'm just writing them with commas in between and spaces. And what Python's going to do is, instead of just returning like it has been that single thing, it's going to wrap them all up in these parentheses. And this, the 2 parentheses with some data inside of it, this is called a tuple. T-U-P-L-E. A tuple. So a tuple, and all tuples, I'm going to set this because tuple, I'm not going to use the word tuple, but tuples as a thing are made with these parentheses. And inside of them, you could put any data you want to. You can put other tuples, you can put other collections of things that we're going to talk about here soon. You'll see these around. It's not real often that you're going to use them exactly. But you will see them. And we're going to run into them a little bit around here, but it's not one that you're really going to mess with too much. The things you need to know about them, about tuples, is they're unchangeable. So they're called it was called immutable. You can't adjust what's inside of them. So if you do something to them, you're really just going to make a copy and do something to that copy. And they're ordered. So that means that the order that they're in here they're all 7s, but the integer 7, string 7, and the other integer 7, it's going to be this order every single time we go to it. So that means that each one of these spots has an index, is what it's called. The place that it is called its index. And with any of these ordered things, this one and the one we're going to talk about next, lists, the index starts at 0. And this is what leads to that error that I pointed out of the off by 1 error, because this tuple has 3 things in it. But if it starts with 0, last index is going to be 2. And I'm going to show you this example with lists, because lists are things you're going to use a lot. And that's way more often that you're going to be interacting with lists and doing things with lists than you will with tuples, but they're similar. So a list is written with square brackets, and then it can contain any amount of data. So what I'm going to do is I'm going to make an example list, and it's going to just be the name of my kids in a list, right? So I'm going to list up all my kids. I got a bunch of kids, just so you know, so prepare yourself. It's going to be a while. So I put in these names as strings, and I separate them with commas. The last 2 names, if you're curious, had to work in English and Russian, because my second wife is Russian, and we go to Russia every now and then. So those are my 4 kids' names. They're in this list. And now if I reference this list, if I want to see this list again, I just can put the name into the interpreter here, and it'll give me the full list, right? So how's this different from a tuple, and why are we doing that? Why would we do that, right? So this list is changeable. It's what's called mutable. Tuples are not, they're immutable. So I can take things out of this, I can add things to it if I decide to have more children, which I absolutely will not, but if I did, I could add to this list if I wanted to. And we can put things in the middle, we can take things off, we can rearrange it. Is ordered like a tuple though. So this is also 0 indexed. So if I want to get a particular thing out of this list, then I would do kids list. I'll use tab complete again. And if the first one is 0 and I want to get my first son out of there, I'm going to put in 0 in square brackets immediately after the name of that list. So it's the list name. So kids list in my case, square bracket, index number in an integer, and then a closing square bracket, no spaces anywhere. And when I hit enter, it'll give me just the value of the thing in that index. Now you can also do, go ahead.
No, I'm listening. Go ahead.
Okay. So then you can do a number of things with this. We'll get way further into lists. Other languages generally in programming might call this an array. Another call that in JavaScript, and it's kind of generally what's called in programming. This is how Python treats arrays. And there are a lot of things you can do with them. So we're seriously skipping over a ton. We're not going to get deep into it, just basic usage of it and understand how it works. One of the things that's really valuable that we're going to use a lot is the length of to check the length of something. And so if I want to check the length of my kids list, I just do len is the name of the built-in function to check a length of a thing, and then open and close brackets around the name of the thing, kids list. And it's going to show me that there are 4 items, and we know that's true. There are 4 items. So there are a couple of ways to get to that last. So if the number 1 is 4, I'm going to show you what happens if you forget and go off by 1, right? So if I want to get the last item in the list, I want to find the last child in here, and I do the same beginning parts, and I say, oh, well, there's 4 items, and if I hit 4 in there, it's going to give me this index error. It's out of range. So we know that the index is always 1 less than the length. So there's a couple of ways to get to that last list item. You can do, since we use that length function, we can do something like this. Yeah, we use range. We're not gonna get that deep with it. That's one way to do it. We could just do this as one approach. I don't say this is the best approach or anything like that, but you could find the length of the kids list and just do some math right here. Say it's less than 1. You know that's the pattern. So put it in there, and that'll give us the last one. Even a faster way to do it with any list, if it's the last one, is the last index. If the first index is 0, the last index is -1. So you just do that, and you get the last one. So there's a ton of stuff that we do on this. We could add to it. Again, I'm not going to mess with it now. Those are lists. Spend time learning them for sure. It is a huge thing that's very often used. The next data type we're going to talk about is called sets, and there are all kinds of cool uses for these. Most of them tend to be like the more math-focused ones, the higher mathematical ones, and some more complicated algorithmic solutions. And we start worrying about speed of doing things. You may want to choose a set over a list. This isn't one you're going to use frequently, but it is very good to learn. It's good to know, and it's good to understand what it is and how it works. So the way you would do a list, and I'm going to do kids list. Oh, I'm sorry, I did a kids list. We're doing sets now. Kids set. So kids set, I'm going to say is, and it's going to have curly braces instead of the square brackets, right? So there's curly brackets, but it's going to take the same kind of data. So I'm just going to paste in the same data that I had up before. It's just going to be these individual sets. And these could be numbers. These could be any type of data. These could be other sets. These could be anything. We could put lists inside of those lists and stuff. I'm just using strings to show what the data points would look like when we do it this way. And we close it off, and now we have the set. And so sets do not have indexes. These are unordered. So the order isn't the same all the time. So you can't do kids set and then call the first one if I want to get my first son. I'm going to get a type error. So we talked about type errors before. So set object is not subscriptable. That means you can't call it like that and get the X that's in there. The thing that's cool with it, though, is if you just have stuff and it doesn't matter what order it's in, you can do something that's built into Python to see if something is in that set, right? So you could just use the thing. I would say, well, did I include my son Alex in this list? And I can just type the word in. So I type the thing I'm looking for, in this case, the name Alex, space, in, and again, Alex as a string. And then I could put in the set, and it'll give me a Boolean back on whether or not it's in there. And it says it's true. It's in there. So there are reasons you would use a set. We're not going to use a ton of them, but it's good to know that they exist, and they are exceptionally helpful for certain problems. Again, usually kind of more mathematical ones. Another data type, the kind of last of these collections that we're going to talk about, is it's called a dictionary. And these are exceptionally cool. Definitely something you want to learn, and you should be using them frequently. There are a lot of reasons to use them that are more efficient for certain things, like finding stuff. You can look things up faster. They're called different things in different languages. In Python, it's called a dictionary. In JavaScript, it's called an object. Some places it's called a hash map or a hash table or something like that. But the basic thing you need to remember is that it's separated into what's called a key and value pair. And I'll show you what that means. So I'm going to update this again. We still use my kids as the data that we're going to enter into it. But this time we're going to do, I have a spelling impediment, dictionary. I'm going to spell the whole word out so we're not, abbreviating anything. So kids dictionary. And this is going to also have curly brackets like a set, except unlike a set, like I said, it's going to have 2 things inside of a key and a value in a pair. So that means that if we want the first one to be, say, my first son, that's what's called the key. So we type in the key, and this could be an integer, this could be a string, and we put in a colon, spaced by convention. And then we put in some other value, right? So the key is Alex. The value is going to put in what, I don't know how old he is. So there, he's 18, right? So I'll do that with all the kids. We do the key as a string, colon, then the value, key, and we separate these pairs by a comma. So that's the pattern to keep adding things to this dictionary. And you can put pretty much as much stuff as you want to in there.
You didn't have to spell out maxim.
I can. I mean,
Oh, it still reads it like that. Okay.
it reads however I want it to be. I can put it whatever I want to in here.
Okay.
I'm defining it right now. This has nothing to do with the set that's above it.
Okay.
I'm using the same name. So I can put literally
Okay.
anything in here. But yeah, for consistency, I mean, that's his full name. So we'll put it in there. And there we go. So then when we close this up, we put this at the end, the closing curly bracket. And so then now we have this dictionary. So cool. I mean, what can we do with that? So we do a ton of different things. Again, we're not going to spend a lot of time messing with it right now. We're just going to show what it is. We will use them more later. But what we can do with this now is we can look things up by the key. So if we want to get
18
something,
and 2. You didn't
Yeah.
figure out how that happened?
I mean, their middle
That's
names
a
are
big
I
spread.
don't learn lessons. But
okay, there you go. All right.
So I'm using their first
I
name.
had the
so to
same
keep it
problem.
simple. Yeah. So
I
if I want to
got
reference one of
8,
these, if
so,
I out of this
yeah.
plethora of children, if I forget how old they are, right? And so if I wanted to do to find out the age, right? Because I'm spacing out or whatever the case may be, then I do a similar square bracket to get to that thing, right? So I type in the name of the dictionary, put in a square bracket, but these aren't indexed. Again, these are not sorted, just like a set. So if I put in 0, it's going to give me an error, but not a type error. So the set gave me a type error. It said it can't subscript. This gives me a key error. Now 0 could be a key. Well, that highlighted more than I wanted to. 0 could be a key, but it's not in my dictionary up here. So it just said, nah, it's not a key that's in here. So what I want to do is I want to change that 0 to something that I know is a key. So let's say, I want to know Maxime's age. Then I can grab it by getting the key, right? And there are other things you do. You can grab parts of these and get just the values. So you can do like the dictionary name, and you can do things that are built into it, because these are just built into all dictionaries in Python. So you could get just the values. And what it's going to do is going to return a list of the values right there. So there's just the values. And then we do other things that we could do with a list. We could do that list of values. So dictionaries are great. They're exceptionally helpful, and they do a ton of things. So there's one more data type I want to get through before we hop over to the other thing that I really want to get finished today before we wrap up. But do we have any questions before I move on to the next thing? Cool. All right. So functions, the last data
I
type we're
do
going to
have a
talk.
question.
Okay, what's up?
I'm sorry.
No, sure.
So what is the purpose of a dictionary?
Great question. So the purpose of dictionary is to put these key value pairs together for quick indexing and looking them up. So it's faster to look things up in this way because the data doesn't have to be stored in a straight line like an array. And when you're going to do some of the operations we're going to do when we work more with algorithms, when we're doing things like loops and look through it, you don't have to look at each individual item in a dictionary. You could just go straight to the one you need and grab it out. And so sometimes that's a lot faster solving. It depends on the problem that you're trying to solve, basically. So the choice between all these things that I just showed you has a lot to do with what you're trying to do. Does that answer your question?
Yes, it does. Thank you.
Okay, sure. All right.
I made
so,
a program where I had to deal with JavaScript and Ruby.
Yeah.
And
Okay.
JavaScript has syntax that Ruby doesn't like.
Yeah.
So I used a key value pair relationship to say, I'm going to say this, but send me the text for what JavaScript's happy with
Absolutely.
as a
And so
result. So
that's-
that it's a
and that-
one-to-one relationship, and I could just use what Ruby was happy with, and I always got
Translate
the answer the next thing wanted.
Exactly. And that's a great example, Chris. Thanks for that. Because that's a perfect example of a translation. And that's a hash map, right? So what you did was you put the one side of it, the key is something that you knew, and the value is something you wanted to be returned. One way that I've definitely implemented this, and we're going to see if you stick with us through to week 6 in the course. I built this simple poker game that you can play here on the command line, and to get the suits to come out and the cards to come out the way I wanted them to, I used a hash map to put that all together, right? So you could put in like king equals K with a little diamond picture next to it, right? So it's those sorts of things. If you want to make values easier to use, change things,
Sure.
there's lots of reasons to use them. So, all right.
And
So we'll
I
move on.
kept questioning myself: am I being stupid? Should I be maintaining a database for this?
Yeah, right.
Should I be
Yeah.
doing something else? You know, and you only know what you know, and you find what you can dig out of whatever web page you're reading on. So
Exactly.
yeah, I'm just trying to plug all this and tie it all together. And
Perfect. All right. So let's plug through this. I want to make sure that we don't go too over, and we're getting close, and I got something I really want to get to by the end of today. So we got functions. Functions is the last data type we're going to talk about today. We're going to skip. We're going to push off some classes and some other things that are really cool. We'll do them next time. But functions in Python, if you think of variables that we've talked about so far as like nouns in a language, they're kind of the things. Functions are like verbs, or the stuff that gets done, the things they're doing, right? So a function is any action that you're going to do. And this is where we get more like, this is going to look like an algorithm, because they are. This is where algorithms actually live. And to make a function in Python, what you're going to do is you're going to define it. So you write in DEF, short for defining a function, and then you give that function a name. Very similar to variable names. There are ways to do it. Shouldn't lead with capital. It should be lowercase. You can do camel case. You can do the underscores. It's really your decision. So I'm going to do, we'll just do this too. We'll just do something really simple. So we're just going to do add to numbers, right? And the function name should kind of tell you what it does. It shouldn't be super verbose, but it should give a clear indication of what it does. So we can have 0 or more inputs. This time, since we're adding two numbers, we're going to have 2 inputs, right? So I'm going to give it a theoretical X input, a Y input. There's no reason I chose those. It could be anything. Since I'm putting it in here, I can name those as just, placeholders, really. Say, expect this when this function works. Expect 2 numbers to come in. And then I'll put this colon here that shows to expect next. So do what's going to happen after this colon. That's what this colon means, to do something, right? So when I hit enter, you see the left of the screen here, the dots show up where it had been these greater than signs.
Jess, can you scroll your screen down a little bit so I can see the bottom on my computer?
That's as low as I can get, man. That's what I'm saying. I can't move it up much
Okay.
more. Sorry.
Okay.
Yeah, I can't clear it in the Python interpreter. So,
Right.
so this change to 3 dots mean that we're still in this code block in this definition of a function. So we haven't just moved on to something else yet. And there are languages like JavaScript that have all these, the curly braces and things you can miss and break and stuff like that. Python doesn't have much of that, but it has indentation is very important. So from here, we're going to indent in, and I want to make a note on this, that you can either use tabs or spaces. It's recommended to use spaces. There are reasons to, technical reasons we're not going to get into. So you should use spaces, but you can use either. You can't use both. So don't mix them. Whatever you do, do it consistently through. So I'm going to add 4 spaces, and I'm going to give this a return of some kind. So I want this function to give me back something. And so it's just adding 2 numbers. I'm going to literally just write return. So what I want back from you. And I want you to take X and add it to Y and give that back to me. So when I hit enter this time, it's going to still stay in the 3 dots. Just, it doesn't know that I'm done. So it just gives me an opportunity to write more code if I wanted to. And also another point, you can't go back up and change anything once you hit enter. That's it on this particular interpreter. We'll move over into a file soon, but that's for this.
Could you repeat what you said about the 3 dots?
Yeah, the 3 dots is just you're in a code block now. So you're not in the general interpreter. You're in this definition of a function that's showing that they're still in here. And this is going to make it, it'll be a little clearer. I'm going to show you this again when we get into a file. I just want to show you what this function is when you make it.
Okay, so you add the 3 blocks, the 3 dots.
So then once I hit enter again, now I'm out of that function definition and I have it and I can use it. So if you remember earlier,
he doesn't add them.
He doesn't type them in. No,
I don't type them. No, it's when I write def and then add, and when I write this colon here and hit enter, it takes me into this block of code.
Oh,
and
okay.
And it changes itself into these 3 dots.
The system's doing that just to give you a heads up that
to let you know that you are now in that code block. Does that make sense?
Yeah, so you don't have to drive yourself nuts with the proper number of indentations and stuff. Right?
You will. No, you will drive yourself nuts because it doesn't indent for you, and you're gonna make mistakes on that. It's really annoying. So now what we could do is we have this function, add 2 numbers. Oh, actually, real quick, just to reiterate, we have a couple of variables. We have A, which is 7. We have C, which is 7, so it's 2 integers. So now we can add 2 numbers. We'll pass that in, just like we did with the the dummy values when we defined this thing to expect these two things. Now we have real variables that we put in there to actually run this function, and we call the function is what we say, and it'll give us the result. So it returned that result out to our thing here. We got to see it. So that is one very simple function. And it is an algorithm like we talked about. And what I'm going to do is I'm going to stop it there on data types. And I want to switch gears a little bit, and we're going to go into doing this very similar thing, but we're going to start doing it not in this interpreter, but in a file, so that we can do this a little bit more like an actual developing, when you're really developing an application and a real thing that you can adjust and run a few times and have a little bit less of the strictness. So to do that, I refresh everybody's memory. We're going to get out of this Python interpreter by typing quit. And if you now know the structure of a function, you just see that this is just a function. Quit is just a function. It's got open, closed, parentheses, and it'll X's us out of the Python terminal. You can see we're back into our bash terminal. So we can use things like clear and get us back into the clear. All right. So now we're going to do into the home stretch here and finish up with writing a very similarly set algorithm. Very simple, the hello world thing that we was talking about. We'll write that into a file and run it from somewhere outside of the Python interpreter. The reason we're doing it this way, again, is to reiterate the fact that all the programs, everything you do, everything will, even complicated stuff, is just this. It's a set of instructions in a file, in a directory, on a computer somewhere. So first thing we're going to do, we have to make a file that we're going to use. So first we're going to look around. I cleaned up my thing again to make it a little bit easier. So it's a little bit not as different looking as yours. I'm keeping this my site. That's the site we're going to build. I'm keeping it as an example, but I will trash it and we'll build it from scratch together. And what we're going to do is, if you remember, you can make a file by writing touch, and then you can open it by writing V to get into the thing. We're going to do V again real quick. So, I'm going to make you use it just this one more time, then we'll move over to something else. But there's a shortcut. We could just use V itself and then type in the name of what the file is we want. And so this time we're going to do main.py, read as main.py. We talk about file extensions. This is convention. We want to do this. And we used to use a main because that's going to be the main file in, up in an application, possibly. So we do this and we hit V. It's going to take us to this familiar screen where I know a lot of you got stuck. Don't panic. We'll get out of it. And at the bottom, though, it says main.py and it says new file. So this file is new. So what we're going to do is we're going to hit I to hit insert mode, and then we're going to write a very similar function to what we just did over in the Python interpreter. Yeah, Martin, you got a question?
Well, I made a mistake. I didn't do, well, I have a page that looks like this, but at the bottom it says, main with the plus mark in it.
Yep,
It's
perfect.
different, but it doesn't say PY. I'm in a different, because I didn't hit the,
so you didn't type the PY. So
right.
you could just exit without saving if you didn't put anything into it and just hit colon quit. Or
Colon
you can adjust
quit.
it. You could do this part and then you could just add the .py. You can rename it to py later. I'll show you. We can
Okay.
just make another one.
That's cool.
So, and you just make another file. That's also cool. So,
Okay.
all right. So
So I'm stuck in main.py on my console.
yeah,
I think I
you,
misspelled it.
yeah, you just typed in the file extension as PI as PY, but so that's okay. We could deal with those and adjust the file name later. Let's get this function in here. It's going to be super simple for now. And we're going to do very quick. We're going to call it main as a function. It's not going to have anything that we did before. We add the two sums. It had inputs. This has 0 inputs. So we just leave it blank, but it still needs to open and close parentheses. And we're still going to need the colon to say that we're moving into this code block. Now, since we're in V and it's an editor, or in Vim, we're an editor, it's going to do the tab for me automatically, so I don't have to mess with it. And it has these line numbers to know what line we're on. So now we're going to go on line 2. We're still in this main function, and we're tell it what to return to us. So we're going to return a string that really just says hello world. And this is what the hello world application is going to look like. So this is exactly what we did before. It's just a function that's in here. Now, if I save this, I do WQ, so colon, escape first, and then W, colon, WQ to save it, exit out of Vim. I should have this file in there when I do ls to see what's there. I should have the main.py file. And it should have the thing that's in there. Now, if I was going to run this with Python, the way we run it from here is we write Python 3 like we did to get into the editor, but then we're just going to do the name of that file. So I'm going to do main. I'm going to do tab complete to get main.py because it exists. And when I hit enter, what it's supposed to do is print out to here like it did before. Remember, we printed out the sum of those two numbers. It printed straight out for us, but it didn't. So there's something that we got to do differently to make it work this way. And I'm going to show you a much easier way that's going to be than working in Vim. We're going to go somewhere else to do this. So maybe you'll be relieved. But what I'm going to do right now is I'm going to open up on the right-hand side in this little burger menu. There's a files thing. I'm going to open this in a new tab and I'm going to keep this console open. It's up to you if you want to just open this in the tab that you're in. But I'm going to move over to files. I'm going to show you this. This is the GUI that's built into Python Anywhere. That's real similar to what we were just looking at the command line. So this is all the file structure we're just looking at. Here's our main.py file that we just made. If you're following along, hopefully you made it too. It should be down here towards the bottom under readme.txt. And if we open that up, it'll take us into this text editor that's built into Python Anywhere. So we don't have to work in Vim. We'll do some more stuff in here because it's going to get a little bit more complicated. I don't want everybody stuck in there. So now that we are here, we can edit this text just like, let me make it a little bit larger for everybody as well, just so that we can see it all. Let me know if that's good enough. So here's the function that we defined earlier, and it's in here. And what we can do from here, which is also really cool, is you see these buttons up at the top. You got save, you can save as. So again, if you made this with the wrong file extension, you could save it as another file extension from here and do it all those different things. We can also just run it directly here. So this is why I asked you to have an empty slot for a console, because when I hit run here, it's going to open a Python console, but using this file. So it's going to try to run, and it's going to load the environment down here at the bottom. And it's going to do what it does, but we get the same result. It doesn't work. So we're still kind of stuck here. We're like, well, this is supposed to say hello world, and it's not. So this pattern I'm going to teach you is going to use what's called control structure. And these control structures are kind of how code is read. Now, the sequential code structure is how code is normally read. So top to bottom, left to right on this file. So when the computer starts reading, it's going to start at the D of def, and it's going to keep going each line until it's done and do what each line tells it to do. This control structure, we're going to get more into this, is a conditional one, and this is called an if statement. So a standard for applications that you're going to run with Python when it has to be run from other places, except, so not just inside the interpreter, but from other files or other things in other places, you're going to use this really conventional if statement. So we're not going to get very deep into the very specific meanings of all these things. I encourage you to look it up, have ChatGPT explain it to you. But this is the statement that goes in. So you put in if 2 underscores name. So if space 2 underscores name 2 underscores, right? And then we're going to check for equality. So is, so if name equals, and then we're going to give it a string. We're going to do 2 underscores and type the word main and 2 underscores. Now I know this phrase probably feels a little esoteric. It's like, I don't know what these name means. This just, again, there's a lot to why this works and how it works. I encourage you to look it up, but for the sake of time, and it's a little out of scope of this course, this is just what's going to enable us to run this function outside of the interpreter and run it from other places. And this is how we're going to be able to build off of this and run other programs and do these things. So just like the function definition with the colon, when we hit this colon, it's going to drop us down into a new code block, automatically indenting for us because this is a code editor, which is nice. And then we're going to tell it to do something. So if it is this thing, we need to call that function is what it's called. So to call a function, we did just like we did, if you remember in the editor where we gave it the things it expected, we have to write the name of the function and then open and close brackets. This doesn't take any inputs, so we're not going to give it any inputs. And now we can save this. We can just run it directly. But once again, we run it, it doesn't come out. But it doesn't give us an error. So remember, sometimes it doesn't give you errors. I showed you a few times it gave us errors. We're getting no errors here, but we're not getting the result we want. So this is kind of like a logic error. There's nothing in the syntax that's wrong. There's nothing breaking here, but it's not working the way we want it to. So what we need to do is we need to tell this thing to give us out on this screen, this output, the result of this function, right? So this function is doing what it's supposed to be doing. We have no indication to think that it's not. The way that we do that is we type the word print, and it's another built-in function like the length that we looked at before that's built into Python. We do print, open parentheses, the function or whatever it is we want to print, and then close parentheses. And that will print us out. Save it just for good measure. And I'm going to run this. And now we got something that says hello world, right? So there's a functioning, this right here, there's 5 lines of, or, 5 lines of code, including the space, is a fully functioning thing. And to show you that that works from other places, I'm going to go over here, back to my bash console where I'm in my home directory. And I'm going to run this code, this command again, the Python 3 main.py. And this time it prints out hello world. And to further show real quickly that we could do this from anywhere, we don't have to be in the same directory that has the, make this a little smaller so it's not all jumbled up like that. That has the actual file in it. We can go to root and we can call it from there if we just know the location, right? So we can do home, my thing, and then main.py, and it'll run just the same. We could, go down into a new example directory and run it from there. Say back up to where it was before, main.py, and it'll still work just the same. So coming up very close on time. That is what I wanted to get through today. I wanted everyone to be able to get to this point, and it's crucial to get to this point. Because if you could do the things that we've done up to now, and you can get this file set up the way I did it, and you can run that command to make the outcome of this function work that way, you can, over the next few days, go to something like ChatGPT and say, write a Python script that, and then fill in with whatever you can imagine, and try plugging this into that framework that we just built and run it in the thing and see if it works, see if it does what you want it to do. So let's say you want to do, converts a CSV to text. Cool. Let's see what it does. Great. It'll give us this code and it imports something. This is a package CSV that's really good at handling CSVs. That's why I use this as an example. And I can just take all of this right here from the import and the definition and just copy that part. I can just drop it straight into here, right? And by convention, we're going to put our import statements at the very top of the page, because the first thing that need to be imported before you use them. If you try to import them after you try to use them somewhere, it's going to break, and we'll get more into all of these mechanics later. But now that we have this in here, it's just a matter of changing this statement to these example usage things. See how it has this print statement down here? Then it's got some file paths. These are all things that we've learned. These are all things that we've studied, that we've covered. So you can upload a CSV file to try this out. You could do the same thing, upload a CSV file into Python Anywhere, and then change this into the path of that. Put this bad boy right here, which we know is a variable being declared as a string, right? Because we covered that today. And then we just put that down here in our function call. So now when you do the Python 3 space main.py, it's going to declare this variable. It's going to find this file and it's going to run the code that you run. So we're like 2 minutes over, so I'm not going to do the extra stuff that I was going to plan on today. We're at time, but I want to make sure that I answer questions if we have any. This is where I want to get to today. Do we have any questions?
I do.
Yes.
So, before you went to this, we were on the page that, it was def main return hello world, blah, blah, blah.
Yes, this right here. Before I pasted all this stuff in. Sure.
Sorry. We're going way back, because you said if you can do this, you should be able to do the other. But before you came into this page, I was on the one where the squiggly thing.
Were you still in Vim?
Yeah.
Okay. So this is, once you make that file, this is the same thing as Vim. It's just an easier way to interact with the files.
Right. I didn't see how you got here though.
Right.
And I also didn't get my Vim thing to work. It didn't, when I did that, I don't know, we typed in line 2, return hello world. And then somehow you got to the bottom of that page and your red cursor was down at the very bottom near like where it said insert.
Hit escape.
What did you get down there?
Escape.
Oh,
Escape first. Yeah, to get you out of insert mode, hit escape.
oops,
then-
wrong computer.
And then you hit colon to tell it that you're going to do something. And then
Hang on.
do W to save it and Q to close it, to quit.
Okay, it didn't work. Okay, I don't know.
All right. So another way to do it, again, if you don't want, if you're seriously just getting sick of dealing with Vim to make things do it that way, you can just go into, again, you go to the either the dashboard,
Hamburger
go to
menu,
files, or
yeah.
this, and go to files, and you can just make files.
Okay, so
in
go
here.
to files.
Yeah. I'm gonna save this before I move.
Okay.
But then you can just make a file, or you can upload a
Okay.
file. So you can upload a file.
Okay.
You can add a new file here. There's a new file button, right? So you just
Okay.
put in the name you want to. So you could just do it here. You could just do main.py and put in new. I have one. It's called main.py. But you just do it this way too. This is a graphical user interface again. So I force everyone to do the CLI first. It is harder, but there's a reason for that. It's boot camp. It's not supposed to be super easy, and
And that's how the
know,
computer thinks. Yeah.
how the computer thinks is valuable skills. Cool. So next time, I know some folks were East Coast, things like that. We can hang out. We can keep answering questions, keep talking. But next Tuesday, we're going to talk about this more. We're going to talk a little bit more about the algorithms, data structures, a little bit more in depth. Play around with this though. Get to the point where you can run this, where you have this without the import statement. You can get rid of this import statement. Sorry. Should be at this point right here where you have the hello world that can print out to your screen and you can run it. Because then again, you can change this and adjust it and make it anything you want to. And you can use ChatGPT to help you write it. You don't have to be able to understand absolutely all the code, but this is all the parts and pieces that you start playing with. So start playing with it, start building things, start making your own functions, call them at the bottom, make your own variables, play around with it. To learn more about Python specifically in the language, I highly recommend doing the Python for Everybody course from Free Code Camp. And if you're more into reading, definitely read the Automate the Boring Stuff, which is linked in there as a PDF that's free to read and super helpful as far as Python just as a language and what you can do with it. So, questions? Anything else?
Jeff, I followed your commands.
Mhm.
Mine says name is not defined. When I say print or when I say run,
Uh-huh.
my name is not defined.
Okay, so in this one, make sure you have two leading underscores. There's
Is it
two
two?
underscores here with no spaces between them.
Oh, I see.
Yep. And so that's probably why it's treating this like an unknown variable, which means, so you'll get that undefined thing and I'm going to hop down in this terminal. So like we declared this variable before, we said like A equals 6, right? And then we declared a B. If I didn't declare an X and I just tried to say X, it's going to give me that same not defined error. So it's just a variable that you didn't assign it. So yeah, this has got leading and trailing double underscores in both main and name. And this is a string and this is not a string. So this is something that it would be super helpful. Just take this, have ChatGPT explain it to you, right? Just why not? Like explain this to me. And there you go.
Yeah, give us a rundown on how to access the recording.
The recording, yeah, sure. So I'm going to email out the recording once it's finished. It takes a little while to process after we're done.
Okay.
And then I'll email out the link to everybody. It'll be in the email, and I'll also pin it in the Discord server. If anybody, I know only a handful of people have been in the Discord server. So I'll keep emailing things to make sure everyone gets it, but I'll also be pinning them there so you can access it. You're going to need the passcode once you click on the link, but I'll include that in the email and in the post in the resources thread or resources, I guess, chat on Discord. And then you should just have to click the link and it'll open in your browser. And then if you have the passcode, you can watch the video, and it'll have a full transcript, like it does automatic transcript of what we're saying. So you can read along with it, and it has anything that people put in chat. I wasn't seeing a ton of stuff. I was seeing a little bit in chat today, but again, if there's more stuff in chat, it'll be there too. So if we do things like kind of the most comprehensive set of everything, but you should be able to just follow the links. And again, hit me up if you don't see something by tomorrow. So I should be able to put this up tonight. If you don't see something by tomorrow, let me know and I'll make sure I forward it to you. But definitely encourage you to get into that Discord channel because that's where things are going to be. The resource list is there. The video from day one and all the videos going forward are going to be in there as well that you'll be able to just grab. And if you're working through these things and have questions along the way, so anybody that's that has to jump or wasn't here for this class and is watching the video later, Discord's a great way to jump in there and ask questions of people and collaborators working together, especially as things get more complex as we go. And going into next week, when we go into algorithms and whatnot, we're going to be doing some, I'll stop sharing my screen. We're going to be doing some problem sets that are put together to practice on. And so again, it'll be good to be able to chat to each other and ask like, hey, I'm stuck on this or I'm stuck on that, or how did you figure this out, or whatever the case may be. Hopefully it'll be challenging for you. I'm imagining it's going to be a wide range of skills. And I use mostly low level ones to make it not impossible for people, but there should be some good challenging ones in there for everyone, hopefully.
Okay.
Hey, Jeff, I was trying to set up a Discord account and no matter what password I tried to plug in, it was telling me that it wasn't good enough. You have any suggestions?
I mean, I don't know what the Discord.
It's saying it's supposed to be like at least eight characters.
Yeah.
Capital letter, special character, all that, number.
I can tell you
that no matter what I used, it said nope.
I don't know. I mean, it could also be just like a network issue or something. Just try refreshing your stuff. But what I do with passwords is I'll take like a song lyric and I'll change some of the letters to special characters. So then it's easier for me to remember. And like, I'll write it and then it's long. So like the thing was, we're not getting super into security, but the thing with passwords is length is the best for security. Yeah. The longer you make it, the better. But
yeah, I mean, I'm just throwing in like random words, something I can remember, but at the same time, it's not like, I'm not like using password 1 or something.
Yeah, I was gonna say capital P password. Definitely don't do that.
Won't work. So I'll keep trying, but other than that, I can't get into Discord.
Oh shit, sorry, man. All right, yeah.
Try
Well, tell me
if you're still browser.
What's that?
Try a different browser.
Yeah, I'm using Google Chrome. Try like Firefox or something.
Or
yeah,
Firefox
is a good second.
Or Edge.
Okay.
Even though Edge is
Chrome. I don't know if I go to Edge. Yeah, my instinct is to say no, but yeah, try another one.
Okay. All right. Thanks.
Sure.
Yeah, randomly Edge will work with the most crazy things, and I'm just like, what the hell?
Yeah, Edge is a Chrome port.
Yeah.
It's also a good way to like get extended use of like ChatGPT is to set up on one browser using one email and on another browser using another email.
Totally.
Yeah.
All right.
Any other? Can you get him to argue?
I have.
Debate for, debate against, and then let them watch them hash it out.
Yeah.
All right. Any other? So we're as I'm gonna go ahead and wrap up the recording. We can still hang out and talk about things we need to. If you're done, you can hop. Thanks for sticking with us to the end on this one. We'll see you next week. If not, do the practices, dig into the things, hit us up with questions. And
thank you, Jeff. Weekend. Good night.
Yep. Thank you. See you later, Marty.
Good night.